Hi everyone, my name is Premalatha. I am working in VIT University, Chennai campus. Today I am going to deal with the page replacement algorithms. And we have three types of page replacement algorithms. We say it as FIFO, LRU and optimal. FIFO is first in first out, LRU is least recently used, and optimal is we are going to replace the page which is not to be used for the longest period of time. So the first replacement is FIFO. We are going to replace a page which is being inserted first. So the first reference string is to be inserted is 7, second is 0, the third is 1. So which came first? 7. So when we are inserting 2, we have to check whether 2 is already present in the already given frames or not. If that is the case, we are not going to do anything. Here 2 is not there, so we are going to insert 2 in the place of 7 because 7 came first. So it is 2, 0, 1 now. And the next string is to be inserted is 0, and 0 is already present in the reference string in the frame, and we are not going to replace anything. The next is to be used is 3, and you just check in the reverse order 0, 2, 1. So since 0 is being inserted that is the first, then we are going to, so 0 came first, 1 came next and 2 came next. So the 0 is inserted first, so we are going to insert 3 in the place of 0. So we have 2, 3 and 1. Next inserted page is 0. We have 2, 3, 1. So when we check in the reverse order, so 3, 0, 2 and 1. So which have inserted the first 1. So we are inserting 0 in the place of 1. So the next is to be inserted is 4. We just check in reverse. So we have 0, 3, 0, 2. So since 2 is used first, we are going to replace 2, and 4 will be inserted in the place of 2. So we have 4, 3, 0 now. Then the next page is to be inserted into the frame is 2. We have 4, 0, 3, 0, 2. So since first came is 2, we are going to since first came is 3, we are going to replace 2 in the place of 3. So the next page to be inserted is 3, and we are going to insert it in the place of 0. So just check in reverse. We have 2, 4, 0. So 3 will be inserted in the place of 0. So we have 4, 2 and 3. So again check in reverse. We have 3, 2, 4, and since 0 is inserted, so 4 is inserted first, so we are going to insert 0 in the place of 4. So we have 0, 2, 3. That is, we have replaced 0 in the place of 4. So since 3 is already there in the list, we are not disturbing anything. 2 is already in the list, and since 1 is not in the list, and go in reverse, we have 3, 2, 0. So which came first? You just check it. We have 2, 3, 0. We are inserting 1 in the place of 2. So we have got 0, 1 and 3. And the next reference string to be inserted is 2. And just go in reverse. We have 1, 2, this 2 in the place of 3. So we have 0, 1 and 2. So 0 is already present, 1 is already present. The next reference string is to be inserted is 7. So check in reverse. We have 1, 0, 2, and which came first? So 0. So we are inserting this 7 here. We will have 7, 1, 2. And since 0 is already present, and check in reverse, we have 7, 1, 0. So we are inserting 1. So since 2 came first, So we are inserting 1 in the place of 2. So we have 7, 0, 1. So for finding the number of page faults, the number of reference strings which has been inserted into the page, we consider that as one page fault. So whenever there is an insertion in the frame, we say it as a page fault. So count it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So the number of page faults is 15. So the next is least recently used algorithm. So this is, we are going to replace a reference string which is not been used for the longer time, which has been used in the previous, which is not used in the previous. Value to be inserted is 7, second is 7, 0, third is 1. So we have 7, 0, 1 already. So check in the future, including the value to be inserted. So the least recently used is 7, so we are replacing 7 and we are inserting 2 in the place of 7. So we have 2, 0, 1. 0 is already present. Now the next inserted value is 3. So check in reverse. 0 is just been used. 2, 1. So we are using this one place for inserting the value 3. So we are using this 2, 0, 3. So 1 is replaced with 3. So 0, which is already present, so we are not inserting any values into it. The next reference string is to be inserted is 4. So check in reverse. 0 just been used, 3 secondly used, and which has not been used for the longer time is 2. So we are going to insert 4 in the place of 2. So we have 4, 0 and 3. So again the next value to be inserted is 2, and check in reverse we have 4, 0, 3. So the least recently used is 3. So insert 2 in the place of 3. So the next value to be inserted is 3. Again check in reverse we have 2, 4, 0. So 4 is used for the longer, that is, it has been least recently used. So we are inserting this 0 in the place of 4. So we have 0, 3, 2. So 3 is already there, 2 is already there in the frame. So the next value to be inserted is 1. So check in reverse we have 3, 2, 0. Since 0 is least recently used, we are replacing it with 1. So we have 1, 3, 2. Next is 2, it is already there. 0, check in reverse, we have 2, 1, 3. So since 3 is least recently used, we are going to replace it with 0. So we have 1, 0, 2. 1 we already have here. The next is to be inserted is 7. Check in reverse, 1, 0, 2. In the 2, and then we are inserting this 7. 0 and 1 are already present. So this is how the least recently used algorithm is going to be used. And the number of page faults are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So we have 12 number of page faults. So the third algorithm is optimal algorithm. Here we are going to replace whichever strings which is not to be used in the future, in the near future. So we have 7, 0, 1. Now we are going to insert 2. The already inserted reference strings are 7, 0 and 1. Check whether 7 is to be used in the near future or not. No. 0, yes, we are going to use it. And 1, so we have 7 here and 1 here. So which is not to be used for the longer period of time is 7. So we are going to use, we are going to replace this 7, and then 2 is replaced in the place of 7. So we have 2, 0 and 1. So 0 is already there in the frame, so we are not doing anything. And 3, so check for the future reference strings. So check whether 2 is going to be used in the future, 0 or 1. So we have 0, we have 2 here, we have 1 here. So which is not going to be used for more period of time is 1. So we are inserting 3 in the place of 1. So we have 2, 0, 3. So 0 is already present. Now we are going to insert 4. So check, we have 2 which is to be used in the near future, and we have 3 which is also to be used in the near future, and we have 0 which is to be used for the third time. So this is to be used for a longer period of time as of now. So we are using this place for replacing 0 with 4. So 2 is already there, 3 is already here. Now we are going to insert 0 and check it. We have 3 which is to be used in the near future, 2 also which is used to be in the near future, and since 4 we do not have, we are going to replace 0 in the place of 4. 1, 0 is to be used in the near future, and we are going to insert this 1 since 3 is not used in the near future. So 2 is used, 0 is used, but 3 is not used in the near future. We are inserting this 1 in the place of 3. So we have 2, 0 and 1. So 2, 0, 1 is already present in the string. Next to be used is 7. So already we have 0 and 1 which is to be used in the near future. Since we do not have 2 in the future, we are going to replace 7 in the place of 2. So we have got 7, 0, 1. So the number of page faults we have are 1, 2, 3, 4, 5, 6, 7, 8, 9. So this optimal algorithm gives the least number of page faults. Thank you for listening to the lecture. Thank you. Have a great day.